is a report on the United States space explorations of 1958. 1958 has seen notable progress in the space effort of the United States. 5 U.S. satellites have gone into orbit. 2 space probes were launched. The first in October traveled about 71,300 miles. And the second in December ascended 63,580 miles above the Earth. Here is the story of these historic contributions to science. On January 31st, the United States Army was ready to launch a Jupiter C missile with a satellite payload. 80 days before, clearance had been given to proceed with the launch. The Army selected the Jupiter C because of its proven reliability. The California Institute of Technology's Jet Propulsion Laboratory, now under contract to NASA, designed and manufactured the advanced stages and the payload. The payload transmitters would have an expected broadcast life of 2 weeks for the 60 milliwatt transmitter and 2 months for the one putting out 10 milliwatts. The payload measured 80 inches by 6 inches and weighed 30 8/10 pounds. Each component in the high-speed assembly was spin tested. It was thought that centrifugal force might distort the structure of the solid propellant within the high-speed rocket motor. It, too, was subjected to spin testing.
Attention all personnel, please clear the launching area for radio frequency interference tests. Please clear the launching area.
This is Ray.
Command transmitter on.
Telemeter on.
Frequency measures 2.5 low.
Calibrator on.
GOVAP on.
Keep radar off. This is Project Command. The time is now X minus 33 minutes. Authorized personnel may resume work on pad. Resume work on pad. Hold for final transmission test. This is Project Command. At my command mark, the time will be X minus 15 minutes. Mark, X minus 15 minutes. All personnel, clear the launching area. All personnel, clear the launching area. The signal is 2.5 kc low. Channel 1 is now reset. Channel 2 is reset. Channel 3 is reset. The figure for Channel 1 is 430. Channel 4 is reset. Channel 5. This is Project Command. The time is now X minus 13 minutes. Start vibration record. Begin cluster run-up.
The cluster is starting its spin. Transmission of all payload electronics components is now being monitored.
This is Project Command. The time is now X minus 4 minutes.
After the firing signal is given, it will take almost 16 seconds for the vehicle to take off. Pressurization will be started at X plus 3 seconds. At X plus 14 seconds, ignition will begin. Thrust buildup will continue until liftoff at about X plus 16 seconds.
This is Project Command. At my command mark, the time will be X minus 1 minute. Mark, X minus 1 minute. Stand by at power transfer. Firing key to launch. Clear signal for firing. X minus 30 seconds. Close master safety circuit breaker.
Recording's on.
Time is X minus 10, 9,
8, 7, 6, 5, 4, 3, 2, 1, 0. Pressurization starts. X plus 8, 9, 10, 11, 12, 13.
The launching was a success, and the first United States satellite was named Explorer I. Explorer I made the most important discovery of the International Geophysical Year: the existence of a great belt of radiation, identified by Dr. James A. Van Allen, head of the State University of Iowa Physics Department. On March 17th, St. Patrick's Day, Dr. John P. Hagen of the Naval Research Laboratory announced that Vanguard was poised and ready to launch from the Atlantic Missile Range, Cape Canaveral. Vanguard I, an Earth satellite, was placed into orbit with a perigee of 409 miles as its closest approach to the Earth and an apogee of 2,453 miles from the Earth. It is expected to stay in orbit for hundreds of years. Its solar batteries will power transmitters, which will give information to generations of scientists of the world community. Information gained from Vanguard I has enabled us to determine the true shape of our Earth. It is slightly pear-shaped. Explorer III, launched 9 days after Vanguard I, achieved orbit and yielded valuable data on the radiation belt discovered by Explorer I. It recorded micrometeor impacts, which gave information about the density of cosmic dust, and it recorded internal and external temperatures of the satellite. The next United States success in space came with the launching into orbit of Explorer IV on July 26, 1958. As a scientific experiment, it confirmed and expanded the data on radiation and temperatures discovered by satellites Explorer I and III. On March 27, the Advanced Research Project Agency directed the Space Technology Laboratories to proceed with a series of lunar probes. The payload was designed so that its electrical system would have maximum possible life. The experiments, aside from an electric scanner, would measure radiation, magnetic fields of Earth and Moon, density of micrometeoric matter, and internal temperatures. These probes would use hardware developed for the Air Force Ballistic Missile Division as advanced re-entry vehicles. The first stage, Thor, develops a sea-level thrust of 150,000 pounds. 2 vernier engines rated at 1,000 pounds of thrust provide roll control and final adjustment of burnout velocity. The second stage was a modified Vanguard second stage with a gimbaled, regeneratively cooled thrust chamber. It had roll control and a separation system for detachment from the first and third stages.